Collision theory. Well, we have two particles approaching each other, and as they do, they slow down. And that means the kinetic energy drops. They also compress, storing energy, so the potential energy goes up. Notice the overall energy doesn't change. When the molecules fly apart, the opposite situation occurs. Here, we're looking at an increase in reaction rate, so you must have more collisions that are successful. And you can do this even if the rate of successful collisions remains the same. Just have more collisions. 5% of 200 is more than 5% of 100. Now, if you increase the activation energy, you're actually slowing the rate. A and D essentially say the same thing, a higher energy barrier. Now, if we're looking at the activated complex, it appears at this point on the curve, high potential energy and very unstable because it's short-lived. The activation energy is the barrier to the reaction. It's always the difference between the reactants and the bump. Or on a kinetic energy diagram, it shows the split between the area to the right where particles have enough energy for a reaction, a successful collision. Now, endothermic means that the product enthalpy is greater than the reactant enthalpy, and so we see that the arrow is pointing up. That's like positive energy in the reactants. Well, here we have molecules crashing together again, and they are slowing down, so kinetic energy decreases, but they are storing energy, so potential energy increases. Really, we saw this question earlier. Now, in this reaction, we're asked to have a look at the forward reaction. Any references to reverse, don't worry about them. We will be reading these backwards, so to speak, in the next chapter, but not now, in the next unit, that is. Potential activation energy goes up in this reaction, and it is all reactions, and enthalpy goes down. Now in the written response, we can see that the reaction is fast because of the description, so activation energy is small. Now you can measure this by measuring the increase in temperature, or volume of hydrogen, or pressure if it's a closed system, or you can look at the reactants and watch them disappear. Now, a temperature increase basically means particles hit more often and they hit harder. Or you can just completely answer it differently by using the kinetic energy distribution diagram. More particles have sufficient energy. Here we are using a graph where they don't say where to start, so start anywhere. And the last one here is our energy distribution diagram, and the activation energy is shown, the area under the curve shows the particles that have enough energy to collide. Oh, the screen has gone dark. I guess I must be finished. Thanks very much.